So all of our linear ones will be something in this form. Now, they're going to tell you as we go through this what they want you to use as variables, because oftentimes the variables represent something in real life. Okay, so instead of using x and y, they're going to use things like t for time and c for cost. Okay, things like that. So here's how this works. You're going to be looking for some number that's going to be added or subtracted. That's the b part of this. And then some number that's being multiplied, or even it could be divided by the number x. Okay, or the letter x, I guess. So right here it says you can estimate the temperature by counting the number of chirps. We're going to call chirps C, temperature T, of the snowy tree cricket. The outdoor temperature is about 40 degrees Fahrenheit more than, when you see that phrase more than, here's what it does. It flips the number listed before the more than into the back end of the equation. And so you're going to have a plus 40 on there. So when you guys see the phrase more than, or if it's less than, it's going to take and flip that number to the back end of the equation. Okay? So here's what this looks like. We have T, temperature, equals, the more than takes and puts the plus 40 on the back end here, and then we have 1/4 the number of chirps. 1/4 the number of chirps is 1/4. See, you guys got circles. That's why you get that in that. You're chirping. It's like there's a slow roar over here. So 1/4 C plus 40, and that's it. That's your equation. Okay, they're actually pretty easy to do, especially since most of them are in this form. So it's like the taxi costs, 50 cents per mile plus $4 for the first mile. It'd be 0.50 m plus, 4. That type of thing. So they're all of this form, or it might be the pizza costs $12. That's the cheese pizza, plus 50 cents or $1.50 per topping, or whatever like that. So there are a lot in that form. So they all kind of look like this, at least if they're linear. We are going to look at some ones that are quadratic. We're not going to write them as quadratics because I haven't introduced you to quadratics yet. But we'll talk about area of a rectangle and area of a triangle today as well, and the equations for that. We're going to leave them, though, in what's called their factored form, and so you don't need to worry about multiplying them out, things like that, that we haven't done yet, at least this year in algebra. You probably have done it before. See if you guys can do this. Go ahead and read this problem at the landfill. So let's just use W for waste, and they tell us to use M for months. Do you see that? Yeah. You got it right? Yes. Or is that a plus sign? No, one equals there, so no, not quite. So we have W for waste. W will be total amount of waste equals. So start with that, okay? And then you'll see what to do from there. So it's going to be W equals. Yes, that's what we're looking for. So what'd you get on it? W equals. How'd you do it? So we've got this 50,000. That's what it already has. Plus 420 M. That's what's being added each month. So if oh, go ahead. Excellent question. Yeah, can you write it like this? The answer is yes. Because this is a plus sign, addition is what we call commutative. So that means you could add 3 plus 4 or 4 plus 3, you still get 7. It doesn't work with subtraction that way, but yes, you could write it either way. And so if you're looking up answers or checking your answers, they might write it like this in the back of the book. This would also be correct. It's a good question. But they're all of this form, y equals mx plus b on these linear ones. So that I think really helps to know what to expect. So when I approach these, you can go through these really fast. You're looking for some number that's being multiplied by the letter plus or minus something that is fixed, some number that's fixed. And then I think in most all of them, at least in the homework, in the book work, they tell you what to use for the letters. So just watch for that as you go through. All right. It says writing and evaluating a function rule here. We got another one. It says a concert seating plan is shown below. Reserved seating is sold out. Okay, it's hard to see this one. So on yours, it's really dark, so I'll have to. And it's really small. So let me write some of the information a little bigger here. Reserved seating is sold out. Total revenue from ticket sales will depend on the number of general seating tickets sold. Write a function rule to represent the situation. What is the maximum possible total revenue? All right. So here we have in particular will depend on the number of general seating tickets sold. Write a function rule to represent the situation. What is the maximum? Okay, reserved seating is sold out. So reserved seating is already sold out. And total revenue from ticket sales will depend on the number of general seating tickets sold. So we just have in here, you probably can't see this part. In the general seating, it says it's $10 per ticket for the general seating. And there are 30 rows and 16 seats per row. So the reserved seating over here, it says it's $25 per ticket. There's 10 rows and 12 seats per row. Now here's the way I understand this. There's always a certain cost associated with putting on a show, right? I'm interpreting this, I believe correctly, and saying that the reserved seating down here, that fixed amount actually pays for all of the overhead, okay, all of the costs. So what they're saying here, at least the way I understand it, and this is how I'm going to approach it, is it says write a function rule to represent the situation. It says the total revenue from ticket sales will depend completely on, this is total revenue, the number of general seating tickets sold. So we're just going to write an equation for the general seating tickets and not worry about this fixed amount for the reserved seating. We're going to call that a wash. Okay, just say that that covers the overhead, covers the cost of bringing whoever's coming there. Okay, so at least that's how I interpreted it. So if I have y equals, we're going to have something times x here. It's $10 per ticket, so it's going to be 10x. So that's my function, 10x. In terms of the maximum amount of money that they could make, it depends on how many seats we have here. So if there's 30 rows and 16 seats per row, how do I figure out the maximum number of seats? 30 times 16. So you go 30 times 16. You got 0, 18, 0, 0, 3. Add those up. I get 480 is what I get for total number of seats. And so when they ask what's the maximum amount of money they can make at this show at $10 per seat, it's y equals 10 times 480. They're plugging in 480 there. So that's 4800. So $4,800 is the maximum profit. Okay, so pretty simple equation. Simple equation there. All right, it says a kennel charges $15 per day to board dogs. Upon arrival, each dog must have a flea bath that costs $12. The flea bath is the fixed cost. Write a function rule for the total cost for D days of boarding plus a bath. So I'm going to use C for cost. Tell us what to use for cost, but I'm going to use C for cost, and then D is for days. So we've got C cost equals, the price per day is $15 per day plus $12 for the bath that they have to take, even whether they stay 1 day or 10 days. They got to take that flea bath. So there's our equation. And then it asks, what does a 10-day stay cost? So a 10-day stay would be plugging in 10 for D. So 15 times 10 is 150. 150 plus 12 is $162. So it'd be $162. And so here's the question: does a 5-day stay cost as much as as half as much as a 10-day stay? Will a 5-day stay cost half as much as a 10-day stay? It would if it weren't for the bath, right? It would if it weren't for the bath. But you got to take the bath whether they do a 1-day stay. The dog has to take the bath whether they do a 1-day stay or a 10-day stay. So let's just check it here. The cost of a 10-day stay is $162. Let's see what the cost of a 5-day stay would be, and then compare it. So the cost of a 5-day stay is 75 plus 12 or $87. So the question is this half of $162? No, it's not. No, because the cost of the bath is applied to everybody, to all dogs. So it's just not going to happen when you have that plus 12 on there, plus anything. So all these equations, see, so far they've all been in that mx plus p form, right? So we get to this last one here. So you're like 80, maybe 90% of your problems you're doing in the classwork and homework will be of this form, okay? So expect that each time. Until you get to the area problems. Area is two-dimensional, so it's nonlinear. I think we talked about that before, right? So I don't expect area to be of that form. It says, write a function rule for the area of a rectangle whose length is 5 more than its width. When I see something like this that compares the length to the width, I'm going to take the width as my base variable. Okay, the length is going to be in terms of the width. So I'm going to call this right here my width, and the length is going to be this portion down here, okay, the base or the longer portion in this picture. And it says the length is 5 feet more than, that takes the 5 feet and flips it over to the other side, 5 feet more than the width. So if I know the width here is W, the length will be 5 more than that. So W plus 5 is my expression for the length. And so I'm going to call the length, instead of calling it L, I'm going to call it W plus 5, because the big idea here is we need to write an equation in terms of one variable. If you have two variables, we'll learn in chapter 6 in algebra that two variables requires two equations to be able to solve it, because you have to substitute one equation in for the other. You may have done that before. It's called substitution or elimination method. So two variables requires two equations. We sort of have two equations here. The second one is L equals W plus 5. And so we're replacing L here with W plus 5. I think if you just think of this in terms of expressions and labeling the pieces in terms of a single variable, it will make life a little bit easier. So the area of a rectangle you really should know, and definitely should know as you go into geometry. The area of a rectangle is just length times width, or oftentimes we use base times height in geometry, because then we can apply that to other shapes. Because, for example, a triangle is just a rectangle cut in half. So a triangle, you'll see at base times height divided by 2. It makes sense that a triangle's area is base times height divided by 2 if a rectangle's area is base times height, right? And then you can build all the other different geometric area formulas that you will need to know in geometry from that triangle or rectangle area formula using base and height. So we typically use base and height. Now I labeled this width and then the length I labeled W plus 5. So I'm going to replace the base with W plus 5, which is specific to this problem, and the height I'm going to replace with W. And this is my equation. Why don't you just box this? This is my equation using W as the variable. Okay. This is not linear. As a matter of fact, if I were to multiply W times W, I would get W squared. Okay. We're not going to multiply it out. We're going to just leave it like this for now. Okay. We'll talk about the distributive property and multiplying these out next semester, actually, later on, when we talk about quadratics. So you don't need to multiply it out to be able to evaluate it. It says, what is the area of the rectangle when the width is 9 feet? What does that mean? You plug in 9 for W. So it looks like this. A equals 9 plus 5 times 9. So plug in W equals 9. And then evaluate it. Super easy to evaluate here. 9 plus 5 is 14. 14 times 9 is 9 times 10 would be 90. 9 times 4 is 36. 90 plus 36 is 126. And then we have feet with a little squared by it to show that we understand it's two-dimensional, it's square units. And then I'm going to do this one with you. It says write a function rule for the area of a triangle whose height is 4 inches more than twice the length of the base. You can see they're using height and base here. So let me draw a triangle, just a generic run-of-the-mill triangle. Draw its height then. It says here that the height is 4 inches more than twice the base. So the more than will take and flip this 4 over to the other side of the twice. So the height is going to be in terms of the base. I'm going to write B down here for the base. There's the base. And the height is typically this right here, but the height is equal to 4 more than, so we're going to put a plus 4 at the end of our expression. What does twice the length of the base look like? That's just a 2b. So my height is going to be expressed as 2b plus 4. So remember, when you see more than or less than, you're going to take and put that at the end of the little algebraic expression. Okay? So more than means plus. If it says less than, it would be minus 4. I think on your homework it's a less than. So that's how it looks. Does anybody know the equation then for a area of a triangle? 1/2 base times height. Some students will write it base times height divided by 2. Okay, or 1/2 base times height. Either one is fine. Doesn't matter. So area equals, the base is B, so B is plane itself, and the height is 2b plus 4, and that's all divided by 2. So that's our equation. We're going to leave it in that form at this point. We box it here to be clear. That's our equation. And then it says, what is the area of the triangle when the base is 16 inches? What is the area of the triangle when the base is 16 inches? So plug in B equals 16. It looks like this. A equals 16. And then we have 2 times 16 plus 4 all over 2. I would use the order of operations and deal with all the stuff in parentheses first here. 2 times 16 is 32. 32 plus 4 is 36, and that's all divided by 2. Then what I like to do is, just to make it so that I can do this in my head and not use the calculator, is do the division next. 16 divided by 2 is 8. And then 8 times 36, I can do that. 8 times 30 is 240. 8 times 6 is 48. So 240 plus 48 is 288. You can check me with the calculator if you want. Inches squared. So 288 inches squared.